So let's take out our calculators, and we're going to enter this data into our calculator, into a list in our calculator. I'll go through this nice and slowly. If you need me to stop or go back, please let me know. Hopefully you can see what I'm doing on the screen. So we're in the statistics unit, right? So we need to press this stat button, S-T-A-T, stat, get their stat, boom. Once I do that, I have the option to edit. And so when I start these, I need to edit my list. So press 1 or enter. And now I will see list 1, list 2, L1, L2, L3. I only need 2 because I have 2 lists. I have low temperatures and I have high temperatures. So I'm going to enter in these numbers. If you have something in the list, I need to tell you how to clear it out. You go up to the top where it says L1. So when it's highlighted, press clear. Nothing will happen until you go down, and then once you go down, it should disappear. If that didn't happen, if you've got numbers in the list, please let me know. Here's first, 26, press enter. 28, press enter. 30, press enter. I'm going to stop saying it out loud. Just go ahead, use the table to enter the information. And then the last number that you type in should say L110 in parentheses because we had 10 numbers. This means that I've entered 10 values and I am looking good. Let me just kind of come back up here to maybe double check to make sure they're all there. Looks pretty good. Alright, now for the other list. Just click over one. Again, if you need to clear it, go up to the top so it's highlighted, clear, and then come back down. Entering the high temperatures, 49, 50, 57. I'm going to stop talking. Go ahead and keep entering the numbers from that high temperature list. Should be an exact match. In the statistics unit, so again, we press the stat button. But instead of editing this list, we need to go to calculate. So I arrow once to the right, and now the highlighted option is in the middle, C-A-L-C. So we go down to number 4. Why number 4? I want the linear equation. Here's the thing that we can really get upset about. AX plus B. Yes, I know it's supposed to be MX plus B, but the calculator recognizes it as A instead of M, and that's super annoying, but it is what it is, so it is number 4. So go ahead, press 4 or enter. Now my calculator program is a little bit older. You might see something on the screen here, like options to choose a list. It will always choose, hopefully, list 1 and list 2. So hopefully you see list 1 and list 2, and you'll see the option to calculate. So some of you might have to click down to get to the calculate. Yeah? Okay? So once you're over that, you're highlighting that, press enter, and voila! The calculator has just done the slope and the y-intercept for us. All that work that we had to do. Let me show you. Let me show you here. Do I have my highlighter today? I do. All this work that we did to find the slope, to find the y-intercept, the calculator did that in like 0.1 seconds. And look at how awesome the calculator can be. Okay? So we got to write this stuff down. Remember that A is really slope and B is really y-intercept. It's always B, so that's not going to change at all. All right. So the equation for the line of best fits was y equaling 1.16x. Why does it sound like a chalkboard? 19 9. So I broke the tip off the pen. That's terrible. Alright, so there's the equation for the line of best fit. What did we come up with? Our equation wasn't that, right? Our equation was this one right here, which is a little different. So, we came up with y equals 0.9x plus 28.4. Yeah, so why the difference? Well, because we're humans, and the calculator is far superior. Watch out when technology takes over the world, right? Well, the real reason is the calculator was able to use every single one of these points to figure out their answer. We only used 1, 2 of the points to figure out ours. So the calculator could be much more accurate with its answer than ours. So clearly, we'd rather go with the calculator answer than with our answer. The slopes are definitely different here, and the y-intercepts are definitely different based on our calculations. Let's put down some things that we did to get this in our calculator. So first, we did a list. And for the list, we had to press the stat button. I'm going to circle it because it was a button. And then we did edit, which was the number 1 option. And then for the equation, again, I'm just giving you some ability to kind of have a set of notes to go back and look at. We did the stat button again. We had to arrow over to calculate. And then we had to do number 4, which was the linear regression, because it was a line that we were looking for. So a couple of keystrokes that we had to do written down on the screen for you. All right. Let's finish it up with a little bit of an understanding here. Explain what the y-intercept of this model means in terms of low temperature and high temperature. Well, if we're looking at the first quadrant and that line crosses and that line crosses the y-axis, let's call it here, we've reached 0. We've reached 0 on the x-axis. So here's what we know. The y-intercept indicates the high temperature when the low temperature is 0. And we found our y-intercept to be 19 degrees. And that makes sense. If we're going to start the day off at 0 degrees, we're not going to get to a very warm temperature, right? So 19 degrees is where it would have started when the temperature is 0. What is the relationship between the rise and the run? So, think of this as the slope indicating an increase of 1.6, a rise of 1.6 at high temperature for every 1 degree in low temperature. So we can write this as 1.16 over 1, a rise over a run. So put 42 degrees in for x, so that it's 1.16 times 42 plus, and we've got 19 degrees for the y-intercept, 19. Calculator says, plan on it being 67 degrees. All right, that's good to know. Maybe a light jacket, maybe pants, maybe shorts, depending on what kind of style you're going with. So we kind of know how to dress for the day. But let's go ahead and round that to the nearest degree. Call it 68